The next feature we'll take a look at involves static class members. If you remember, we have talked about the keyword static before, particularly with methods. So if you remember, if a method is static, then we didn't need to create any objects to use them. So like for example, we would just have like the math class and the character class. So if we wanted to call any of these methods, we just needed the name of the class, a dot, and the method. Now, if we didn't have a static method, or if we didn't use the static keyword, the method must be invoked by an object of that class. Let's take a look at an example using our clock class. So here I'm creating an object called myClock, and I want to increment the seconds. So I invoked increment seconds by including the name of the object, myClock, a dot, and the name of the method. Increment seconds is not a static method, which means I am required to include the name of the object. If this were a static method, then we would need to invoke it using the class name instead of the object. So we could say clock.increment seconds. Now let's talk a little bit more about variables. So class variables can either be static or non-static, just as methods can be static or non-static. If the variables are non-static, then we can just use them as we have been. We can use them in our class methods. Anything different about it. But what about static variables? Well, these work a little bit differently. Java will actually allocate space only once for each static member. So instead of having space for every single instance variable for every single object of our class, we just allocate space for one static method, or static member I should say, and all the objects refer to that same memory space for the static member. So what we're saying here is that the static variable is shared among all objects of that class. And if we set it up to be public, we can access these members outside of the class. So just think of them as I said, think of the static members as variables that we just share among all the objects. Here's an example where we use static variables. So on the left side, we have a class which we call myClass, and there are two static variables, a private integer variable called y and a public integer variable called count. And we also have a static method which is called increment y, which simply increments the value of y. And then on the right, we have two different objects of myClass, class 1 and class 2. So let's say we include the following statements in our code. So then we have myClass.increment y and myClass.count plus plus. Both y and count are going to be now 1. So we'll assume that they're initially 0. And both of these lines of code will increment y and count. So increment y, well, that's our static method, so that's going to increment the value of y. And count, since it is a public variable, I can directly access it outside of the class. So both of them get incremented by 1. And because they're static variables, those changes apply to all objects of the class. So both class 1 and class 2 now have y and count set to 1. Now, what happens if we do myClass.count plus plus again? Well, this means count is now 2 for both objects, because once again, because it's a static variable, it is shared among all the objects of that class. So the fact that we are dealing with just the class part, we can just increment it, and it's applied to both class 1 and class 2. Notice that when we modify static variables, we don't use any of the objects. Because once again, just like with methods where we can just have the name of the class and then our method, when we're modifying static variables, we only need the name of the class and then the name of the variable. Now, if we wanted to, we could still increment y using the objects though. So we could say something like class1.increment y. This is a perfectly valid statement. And this will change y for all my class objects though. That's the key thing. So even though I may invoke the method on a class and I change the static variable, that change is still being applied to all objects of the class, whether I invoke it on the name of the object or if I invoke it on the name of the class. But it's still being applied to all objects of that class. We'll conclude our lecture by looking at some additional class elements. The finalizer is another special type of method, just kind of like how constructors are special types of methods. The finalizer must be a void method, so you can't have an integer type, you can't have a double type, it must be a void type. And a class can only have one finalizer, And this cannot have any parameters. And we're going to even be more strict. The name must be finalized. So in your code, you would have void, finalize, some parentheses, and then you would have stuff in the curly braces. So what's the point of the finalizer? Well, what this does is it automatically runs when our class object goes out of scope. So when Java recognizes that we're not going to use an object again, we automatically call finalize. Whether it's defined or not, it just automatically happens. This method is normally used to free up any memory allocated by the object of the class. So if you remember, we talked a little bit before about how Java has automatic garbage collection. So it will eventually invoke this garbage collector and free up any memory that it knows that's not being used. This is one of those features where when Java recognizes that an object of a class is no longer going to be used, then it will just automatically free up that memory that was allocated for that object. And this is done by using the finalize method. We'll end the lecture by looking over a couple of observations about accessor and mutator methods. So remember that an accessor method can only access and not modify data members. And mutator methods can modify data members. Now, most classes have both types. They'll have methods for accessing data, and they'll have methods for changing data. So for example, in our clock class, setTime is a mutator because we changed the instance variables, and getHours is an accessor method because we just simply return the hours. Now, since most of these instance variables are private, the only way to actually access and modify these values are to use accessors and mutators. So this is how we actually can control how the values are modified. So like for example, if in our setTime, if we want to change the hour, it should be some value between 1 and 12, if we're assuming standard time here. We shouldn't be able to set the hour to like 57. So by using these methods, we have more control over what the values of these variables can be. Now, in most cases, accessors are always going to start with the word get, and mutator is going to start with the word set. This isn't always true, but it's a good idea. That way you can distinguish among the accessor methods and the mutator methods. So just moral of the story, have your accessors start with get, just like how we have get hours, get minutes, get seconds, and have your mutator start with set, such as set time, or if you want to have a set hour, a set minute, or a set second, and so forth.